So law of sines is used to find the side and angle measures in a triangle that's called an oblique triangle, so a non-right triangle, okay? The equation for law of sines is super easy. It is this, basically, and two of these three set equal to each other as a proportion, and then you cross multiply and divide. So the lowercase letters represent side lengths, the uppercase letters represent angle measurements. You will, for me, be really careful about it, especially because when you're writing your C's, they're not much different. You want to make sure that when you're giving me an angle, you put the angle, the degree symbol on it, and then the side obviously doesn't need it. So you put the ratio of the side length over the sine of the angle that is opposite it equal to a side length over the sine of the angle opposite that one. And then you pick two of these at a time, cross multiply, and divide. You can flip these, like the order doesn't matter top to bottom as long as you're consistent. So if you put all the angles in the top and the sides in the bottom, that's fine. You can flip them, doesn't matter. Again, you just use them to cross multiply and divide. So in a triangle, the three angles, if they're labeled A, B, and C, the side opposite A is there, the side opposite B is there, side opposite C is C, and they will have the same letters. Most of the examples of today they're actually drawn out for you, but I'll tell you right now, the quiz is going to be a list. The homework, some of it's going to be a list, so just make sure you can be able to identify which one goes where. And this is like how it's derived. So if you had drawn a triangle and you found that the altitude, which is the height, you can use SOHCAHTOA to find the missing side length there. And then you'd have to plug that back into your equation. I'm not going to test you on where it's derived, okay, how it's derived. But if you're ever like sitting at home like, where do they come up with this stuff? This slide is that answer. And then oblique triangles is what we use this on. So oblique triangles are triangles that do not contain a right angle. If it contained a right angle, I would use SOHCAHTOA. So these are not going to have the right angles, which means you're going to use law of sines, or when we get into it, law of cosines. But you can't use a Pythagorean theorem to solve these triangles. All right, first example just gives you the triangle. The two angles are given, and then the side C is given. So the first thing you have to identify is one complete ratio, meaning side and angle. Which letter do you have both of? C. So I'm going to set that up as my completed ratio. I'm going to say C over the sine of C would equal A over the sine of A, and C over the sine of C would equal B over the sine of angle B. So C is 32 over the sine of 43 would equal side A, which is missing, over sine of angle A, which is 20. Then I cross multiply 32 times the sine of 20 would equal A times the sine of 43, and then divide. And I'm going to type that all in the calculator. So I wait till the very end so you're not rounding as you go. And I would type it in as sine, or 32, sine of 20. You can close your parentheses and then divide, or you can hit enter and then divide it. It's completely up to you. Sine of 43. And I get 16.047. We're going to round this to 2 decimal places, which is what most of the homework says, I think. 16.05. It doesn't matter as long as you're consistent. Yeah. So I tend to put the side on the top, but it really doesn't matter. As long as both sides are equal signs do the same thing. Okay, so then for B, I'm going to go back to... No, good question. These are in degrees, right? We want to be in degrees. None of the ones I give you have radians, but you could see it. Like if that angle A was pi over 7, then you'd want to be in radians. Okay, so then C again is 32 over the sine of angle C, which is 43. B, I don't know, and I don't know angle B yet, but how could I find it? It's oblique, but there's still, what about all these three angles? Still up to 180. So 43 plus 20, 63. Subtract it from 180. 117. So why is it smart to always stick with the initial information? Why can't I use side A and angle A? I already know it.
Because if your angle's wrong, then you're
Good. If I found that measurement wrong, I'm going to continue to use the wrong thing. And also we rounded A, which makes it less accurate. Even if it's a correct answer, it's still rounded. So now from here, I'm going to cross multiply 32. Sine of 117 equals B, sine of 43, and then divide. And 32 sine of 117 divided by sine of 43. Side B is 41.81. So when the directions say solve the triangle like this one did, it means find every piece of missing information, which was, in this case, angle B, 117 degrees, side A, 16.05, and side B, 41.81. Questions so far? So obviously they're not always going to be drawn to scale, like 117 should be an obtuse angle. That's not the case when you got the picture. But what should make sense is like the longest side should still be opposite the largest angle, smallest opposite the smallest. So because A is 20 degrees, side A should be the smallest of the three sides, which it is, because you know B is 117, B should be the longest of it, which it is. So those kind of things can help you check to make sure you're on the right track. Questions on that one? All right, so the angle came from subtracting from 180, you got 66 degrees, and then 21 over 79, that was the full ratio that we had, which was C. So 21 over the sine of 79 equals B over the sine of 66, and you should have gotten B is 19.54, and then 21 over sine of 79 equals A over the sine of 35. So when you're listing out all the information that was missing, which is what it means to do solve the triangle, I'd get B equals 66, or angle B equals 66, B equals 19.54, and A equals 12.27. Easy stuff, right? Questions so far? Okay, so this is where law of sines gets tricky. Law of sines equation is easier law of cosines, but law of sines has something called an ambiguous case that makes things a little bit more difficult. So if you are given, and it didn't apply to what we just got given because what we just got given was two angles and one side, those are not ambiguous cases. Those will always only have that one scenario. But if you are given two sides and the non-included angle, so if I'm given side A and B, then I'm talking anything other than this angle. So if it's this angle and this angle, that kind of thing. If you are given that information, then one of three things can happen. One is that you have one triangle, okay, whether it be right or it be oblique. It's still just one triangle like we've been doing. Another case, the lucky one, because it's less work, is that there's no triangle. And the third case, the one you dread, is if there's two triangles, okay? So if there's one triangle, then what you'll do is you'll be given two sides and the non-included angle. You'll solve for an angle. And then you'll continue on to the third angle, and you will assume there's a second triangle. So that's what we're going to do. We're going to assume there's a second triangle until you prove yourself wrong. And the way you will prove yourself wrong is that when you go to find that third angle, it will be negative. If the second triangle's third angle is negative, then you know there's only one triangle. You continue like we did. If it's not negative, then there's an entirely second triangle. And the reason this can happen is this little like hinge can happen. If I gave you this, like if I gave you a piece of string that was that long, and I gave you a piece of string that was that long, and I didn't tell you anything about the angle where they meet, I gave you one of these angles, then you can technically make a triangle that looks like that, or you can use the same B, the same angle A, but you can swing side A out and make an entirely separate triangle. One of those angles will be obtuse and one won't be, okay, for it to happen. So what we will do is assume that it's going to happen until we stop ourselves. That's basically what we'll do. Okay, the biggest catch here is that you guys will be like plugging along, think you got good answers, completely forget about the second triangle and have missed half the credit on the question because you didn't get the second triangle. So be really, really careful. Okay, so we're going to work through these three cases, but if there is given to you side angle, then you're going to use law of sines the way we just did to find the first angle. And we're going to call it B1 or A1 or C1, whichever letter it is that we're trying to find. And then we're going to assume there's a second triangle. And in that second triangle, we're going to use all the information that was given to us in the beginning. Plus, we're going to take the angle we just found, subtract it from 180. And that's going to be the second angle in the second triangle. And then you'll continue to solve both triangles. First triangle is going to be finished. Second triangle, when you go to finish it, will either have a positive third angle, which means there's a second triangle, or there'll be a negative third angle, which means there is no second triangle. All right, so let's work through some examples. Pay attention, though, because I said it before, like, these are drawn out to you, but most likely, quiz-wise, well, 100% quiz-wise, it's going to say angle A is 81 degrees. Side A is 20 and side C is 12. That's how the information is going to get given to you. You've got to be able to identify that that's side angle. Okay, you're given two sides and the non-included angle, which is you're going to make sure that you test for the ambiguous case. So I'm going to start the same way I did before, is identify the full ratio we have, which is side A and angle A. I'm going to say 20 over the sine of angle A, which is 81, equals, the only other piece of information I have is side C. So we're going to say side C over the sine, and we're going to call this C1 because we're going to assume there's a second triangle. So then I cross multiply, I get 12 times the sine of 81 equals 20 times the sine of C1. Divide both sides by 20. And I get sine of C1 equals 12 times sine of 81 over 20. So 12 sine 81 divided by 20. And I get 0.5926 and so on and so forth. Is that angle C? No, it's the sine of angle C. So if I give you the sine and I want the angle, what do you have to do?
Turn it to the angle.
How?
Add it to sine.
Other way around, right?
The negative sign.
The inverse sine. Inverse sine, right? So I'm going to do sine -1 of whatever I get from here, not rounded. So on the graphing calculator, I would hit, after I found that 0.59, I would hit second sine, second negative, where the answer button is. And I'd get angle C1 is 36.342 degrees. Three, four. It will usually tell you to round to 2 decimal places. Yeah. Okay, so now I'm going to assume there's a second triangle. And to find angle C2, I take C1 and subtract it from 180. So 180 minus 36.34. 143.66. And we're going to come back to that because we're going to finish our first triangle. Questions so far? Okay, so now I've got first angle from the first triangle, or second angle actually because they gave me one. The last thing I need to find, or the last two pieces I need to find, so they gave me that one is what I have now, is the third angle. So angle B1, I'm going to find by subtracting angle A and angle C1 from 180. And I get angle B1 is 62.66 degrees. And then the only thing I have left on my first triangle is side B1. So I'm still going to use the information from C that they gave me, or from A that they gave me at the beginning. 20 over the sine of 81 would equal B1 over the sine of 62.66 degrees. So 20 times the sine of 62.66 divided by the sine of 81. And I get B1 17.987, so 17.99. So that's my first triangle. Now I'm assuming there's a second triangle that still has the same information they gave me at the beginning. It still has 81 for A. It still has 12 for C. It still has 20 for side A. And then we found C2, 143.66. So then the next thing I would find is angle B. I would do 180, and we're going to call that B2. Minus the A that they initially gave me, minus C2. What happens when I do 180 minus 81 minus 143.66? What do you get? Negative 44. Can a triangle have a negative angle? No. So this is when you know there is no second triangle. When you go to find the last angle on the second triangle. If it is positive, you're going to continue. If it is negative, you are done. Andy?
Why did you try to find the second triangle with C? You thought it was B.
So the information that they give you at the beginning is true for both triangles, right? But the way you start your second triangle is the first angle you find from the first triangle, which in this case was angle C, right? We found C first. We take that and subtract it from 180 to get the first missing angle of C2, or triangle 2. So whatever angle you find first on your first triangle, if it was angle A that I found, I'm going to call it A1. And then I'm going to start in a second triangle with A2, and the way I find it is the 180 minus A1. So it's the supplement to the first angle you find. We're going to, don't worry, we're going to do some more. Yeah.
Answer here
Is just the first triangle. So there's only one triangle. So the answer here would be angle C, 36.34, and you can make it C1. Or you can make it C because there's only one. B, 62.66. And side B, 17.99. So that's the information that would be needed for an answer. Bella?
at the end to figure out if there's a second one, you subtract the original angle A and then C2.
Correct.
And if it's negative,
There's no second triangle. Positive, keep going. Yeah. All right. Second example underneath the ambiguous stuff, right? Again, you get two sides and the non-included angle. So again, this is the ambiguous case. If you get your quiz and you want to figure it out, you want to put a star next to it to remind you to check for the second triangle, do it, okay, or test. But make sure you don't continue and forget. So then for here, I'm going to again start the same way. I've got one completed ratio, it's A, so 12 over the sine of 69 equals, B is the only other one I have information and it's side B. So 15 over the sine of B. Cross multiply. We can call it B1. Yeah. Sine of B1. And then divide both sides by 12. So I get the sine of B1 equals, I'm going to type that whole thing in the calculator, 15 sine 69 divided by 12. And I get 1.1669. So when I go to do sine -1 of that, what's going to happen? Can sine be bigger than 1? Can the hypotenuse be smaller than the opposite side? No. So if you, from that moment, get a number that is 1 or bigger than 1, there's no triangle. It's not possible. I'd probably double check, triple check a couple of times. Okay, make sure you didn't type anything in wrong. But this is part of your ambiguous case. This is, you got lucky because you don't have to do any more work. Okay? So there is no triangle. Not even that there's no second triangle. There's no triangle to begin with. You couldn't physically form a triangle given those measurements.
Can you tell us by the triangle?
No.
Okay, let's just do it out.
Yeah, but the first step you get it. Yeah. Questions?
Wait, so how do you know it's not a triangle?
When you go to find the angle, you'll get an error because you're going to try to find the sine -1 of something that's bigger than 1. And you can't have sine be bigger than 1. That means that the hypotenuse is smaller than the adjacent or the opposite side, right? Same thing when we get cosines. Or your calculator will yell at you. Like if I go to hit sine -1 of 1.16, it's going to give me an error. So that is one of the three cases. So the first one is you get one triangle, right? Second one is no triangle. What do you think's happening? This is the super fun one, okay? There will be two triangles here, but you don't know it yet. So you're going to assume that it's going to happen until you prove yourself wrong, okay? Again, I'm giving all the information for A. So I would start with 12.3 over the sine of 62 degrees equals, the other thing I have information on is B. So 13 over, we're going to call this sine B1. We're going to cross multiply. Divide. And I get sine of B1 equals whatever this is, which means angle B1 equals sine -1 of, again, the result from that. So 13 sine 62 divided by 12.3. I'm not going to round it. I'm going to hit second sine, second answer so that it stays exact. And I get B1 is 68.94 degrees. And then to remind myself to check for a second triangle, I'm going to come over here and say B2 is the supplement to that. So 180 minus 68.94. Which is 111.06. So I do it right away to remind myself there's a second triangle. If you want to continue on and do the whole first triangle and then start your second triangle, that's totally fine too. But my advice is to make sure you do something to remind yourself that that's the second triangle. So now I need to find, now from that first triangle, I've got angle B1, 68.94. I'm missing angle C and side C. So angle C1, I'm going to find by subtracting the other two, the one they initially gave me and the one I found from 180. And I get angle C1 is 49.06. And then the last thing I need to find is side C1. So I always go back to the original ratio, 12.3 over the sine of 62 is going to equal side C1 over the sine of 49.06. And then cross multiply. And I get side C1, which is the last thing I was missing from the first triangle. Question so far. So again, I did it at the beginning to remind myself to go back because there's probably a second triangle here. I'm going to continue on with that right side. So now I've got a triangle with all the same information they initially gave me, which was angle A, side B, and then my B1, or B2, sorry, which is 111 and 0.06. So I'm still missing the same information. I'm just going to call them 2's instead of 1's. Side C, or angle C2, which would be 180, minus angle A, which is 62, minus 111.06. And this is the deciding factor right here. If what I get there is negative, I'm done. But if it's positive like it is, even though it's small, that means there's a second triangle and I have one more step. So once I get that, I need side C2. I still go back to the original measurements that were given to me. So 12.3 over the sine of 62 would equal C2 over sine of 6.94. Cross multiply and divide. And I get C2 1.68. So the answer to this is all 6 parts. The first triangle that had angle B1, angle C1, and side C1. And then the second triangle that has angle B2, angle C2, and side C2. Oh. Questions? So depending on the version of your quiz, the version of your test, whatever it is, some of you could get 1 triangle, some of you could get 2 triangles, some of you could get none. Okay? You have to be ready to be able to do any of them. And those of you that are like, oh, I know this stuff from Algebra 2, but you haven't practiced it in a long time, that'd be like stepping onto the football field to play the Super Bowl having not practiced the entire season. Don't be dumb. Okay? Do the work, do the practice on it so that you are ready, so that when you go take this quiz on Friday, you can start your third quarter off high, okay, instead of working your way back up. All right, that area is super easy. That's what's next, okay? How to find the area of an oblique triangle. So we know the area of a triangle is 1/2 base times height, right? But what happens if we don't know the height? This is what you could do. You do 1/2 the 2 sides times the sine of the included angle. So you need 2 side lengths and the included angle here. Any of these 3 will work. So if you have side BC and angle A, then you would do 1/2 side B times C times angle, the sine of angle A. If you had side AB and angle C, then you do 1/2 AB times the sine of C. And if you had AC times the sine and angle B, then you would do 1/2 AC sine of B.
Could you also just divide by 2?
You mean like multiply them all together and then divide by 2 at the end? Yeah, same thing. Yeah. So it will look like this. And again, it will probably, instead of giving you the triangle like the drawing, it will actually say B equals 5, C equals 6, and angle A equals 71 degrees. So this would be 1/2 BC times the sine of angle A. 1/2 5 times 6 times the sine of 71. And then you can, like Mia just said, you can multiply that all out and then divide by 2, or you can do 0.5 times 5 times 6 times the sine of 71. So area here is 14.18, and it didn't give you a unit, so units squared. So you will learn another angle formula if you're given all 3 side lengths. By the time quiz rolls around, you'll have your law of sines, an angle, and an area formula, and then law of cosines and an area formula. And then comes the fun stuff. So you will see word problems dealing with law of sines and law of cosines, okay? Obviously, you're setting up some sort of triangle, and then you're using law of sines to find what you need in this case. It says 2 fire lookout towers are 17 miles apart with Tower A directly west of Tower B. So A is here. Directly west means it's going to be a horizontal line to B. So this time it's given to you, sometimes you're going to have to draw it out. 17 miles apart means it's going to be here, 17 miles. Both towers spot a fire on a mountain to the north. So here's my mountain to the north. There's the fire. And then we get to bearings. So we haven't talked about bearings yet this year. It says the bearing from station A to the fire is north 55 degrees east, and the bearing from station B to the fire is north 40 degrees west. So bearings have 3 parts. The first is going to be a north or a south. Then you've got your degree measurement, and then you've got your east or your west. So a bearing has angle measurements and also direction. If I am going northeast, then from wherever I'm starting, so this one says from A to northeast, this is my A, this is where I'm starting. North would be what direction on my compass? Up or down? Up, right? So I'm walking up, and then it's east from there. Is that right or left? Right. So that's where that angle measurement comes from. And then it says that it's 55 degrees, which is where the measurement of my angle goes. If it had said, let's say southwest, then I would have gone south, and then I would have gone west, and that's where my angle goes, okay? So your angle is the opposite of your reference angle if you think about it. Your reference was from the x-axis to the end. The bearings is from the y-axis to where it ends. So then bearing from station B to the fire, which is from here to here, is north. So I'm going up again. 40 degrees west, which is left. How far to the nearest 1/10 of a mile is the fire from station A? So my fire is up here, station A is up here, which means I'm solving for side B. How do I find it? Close. I have 2 angles, right? But where are those 2 angles that I have? They're on the outside of the triangle. So how do I get them on the inside of the triangle? Subtract by 90, because these are, right, they're perpendicular. North, south, east, west line is perpendicular. So if I subtract 55 from 90, I get 35 degrees in here. 40 from 90, I get 50 degrees in here. Then I can subtract it from 180, right? 35 and 50 is 85. 180 minus 85 is 95 degrees. Now I've got one completed ratio in C. So I can say 17 over the sine of 95 equals B over the sine of 50. And then cross multiply and divide. So 17 times the sine of 50 divided by the sine of 95. And it says round to the nearest 10th. So 13.1 miles is the distance from A to the fire. So if the question was to find an angle, remember like bearings, if it said what's the bearing from one place to the other, you got to give it direction. Not angle, but the direction. All right, this one says a surveyor already found 2 angle measurements. Find the distance between those measurements on the opposite side of the river. Find the length across and the distance, between those measurements and the opposite side of the river. Find that length across the river from point A to point B. So it's already giving you all the information you need, okay? It's got this angle and this angle and this side. You don't have to add anything to the picture. You didn't have to draw anything by yourself, but what you do have to find is that angle B, right? So 58 plus 69, 127, subtract that from 180, 53 degrees. And then I would say 500 over the sine 53 equals, I want to find from the river, or I want to find the distance across the river from point A to point B, which would be side C. And then again, cross multiply and divide. So 500 sine 69 divided by sine 53. And we're going to round to the nearest tenth again. This time it didn't tell you, but this would be in feet. Questions on anything we talked about today? All right, so remember, you want to be practicing with the calculator that you're going to use on the quiz so you get comfortable with it. That's one thing. Your homework is some questions on WebAssign, and then there's additional questions because the word problems on WebAssign stink, and WebAssign didn't give a second case for the ambiguous case. You're going to need to know how to do that. So I added on, there's 3 questions on a PDF. Make sure you do all of that. I think there's 5 on WebAssign and then 3 on the PDF. The other thing is, one second, don't forget though. One of the questions on WebAssign gives you the angle measurement in degree, minute, second notation. So let's say it said this, okay? And then you have to give an answer for an angle. You have to put it back in a degree, minute, second notation. So if you work through, remember this is in your angles menu and then above your plus, okay? But if you're working through and I get something like my answer is 35.75, right? In order to get it back in degree, minute, second notation, you have to type that in. And then you have to go second. And above the apps button is your angles. And then you have to hit the little arrow DMS. And it will put it back in a degree, minute, second notation for you. So same thing for your quiz. Like if it gave it to you in degree, minute, second notation, you need to give your answer for the angles only. Not for the side measurements, but for the angles, you have to put it back into degree, minute, second notation. So just don't forget.